Introduction to the Sharp 1640L engine lathe. With this machine, you can make stock rounder, drill, tap, bore, taper, and thread. We will begin by discussing different features of the lathe. First up is a headstock. This is where you will make changes to the RPM settings or revolutions per minute the spindle turns while turning material. RPMs are adjusted by manipulating the X/Y lever, the H/L lever, and the RPM lever in the center of the headstock. Additional levers are the carriage direction lever located at the bottom left of the headstock, and M/P lever used to adjust threading selection or feed rate of the carriage or cross slide. Up next is a spindle or chuck. Our lathes will have either a 3-jaw chuck, a 4-jaw chuck, or a collet adapter for using 5C collets. This lathe currently has the 3-jaw chuck attached to the spindle. This is followed by the carriage assembly. The carriage assembly consists of the apron, cross slide, compound, tool post, and tool holder. Pictured here is the apron. This is the carriage feed wheel. This wheel moves the carriage in the Z direction. One full revolution of the feed wheel will move the carriage 670 thousandths. Pictured here is the apron oil level indicator. This is the cross slide feed wheel. This moves the cross slide in the X-axis, which is used to control the diameter of the part you are turning. One full revolution of the hand wheel is the equivalent of removing 250 thousandths of material from your part. This is a carriage feed or cross slide feed. Select a lever. In its current position, which is fully depressed, the carriage will move in the Z-axis when the feed lever is engaged. If this lever is in the up position, when the feed lever is engaged, the cross slide will move in the X-axis. This is a carriage/cross slide feed engagement lever. When this lever is pushed down, the carriage of the cross slide will move dependent on your selection. Featured here is the half nut engagement lever. This is used in single-point threading on the engine lathe. This lever is used in conjunction with the thread dial indicator and selected thread profiles, which you will see later. This is the spindle engagement lever. Pulling the lever up will cause the spindle to turn in a counterclockwise direction. Pushing the lever down will cause the spindle to turn in a clockwise direction. When turning material on the lathe, it is important that the spindle turn in a direction so that material passes over the top of the turning tool when the tool is engaged with the material. Failure to do this can cause broken or damaged tools. Next up is the tailstock. The tailstock is used for a variety of purposes on the lathe. It is often used to support stock that sticks too far out from the face of the chuck. In those cases, you will use either a live center or a dead center attached to the tailstock to properly support the material. You can also use the tailstock to perform center drilling, countersinking, or counterboring operations. Pictured here are the quill lock lever and the tailstock lock lever. The quill lock lever is used to keep the quill from moving while the live center or the dead center are engaged. Here is the quill feed wheel for the tailstock. One full rotation of the feed wheel will move the cutting tool 200 thousandths of an inch. This is the lead screw. When performing threading operations on a lathe, you will engage the half nut lever onto the lead screw to begin single point threading. The thread dial indicator is always engaged with the lead screw. The lead screw should only turn when you're performing threading operations. If the lead screw turns while performing normal lathe operations, you should check your settings to ensure they are set properly. You will see how to do this a little later in the video. This is the foot brake. You can use this pedal to stop the spindle from turning. By depressing this pedal, you cut the circuit to the solenoid that provides power to the spindle. You should be aware, at high RPMs, this does not bring the spindle to an instant stop. Always ensure you utilize the emergency stop button. These are the function switches. Depressing this button momentarily causes the spindle to turn. Releasing the button causes the spindle to stop. This is the emergency stop button. Pushing this button cuts all power to the lathe.
This is the lathe on-off switch.
This is the power indicator light. When the on/off switch is set to the on position, this light will illuminate. As this is a light subject to failure, never assume that power is off to the lathe if this light is not illuminated. Always ensure the on/off switch is turned to off, and the emergency stop switch is engaged prior to removing material from the chuck and making tool changes. This is the coolant supply switch. When engaged, the coolant pump will shower the cutting tool and part being cut with coolant. This is the quick change gearbox. By manipulating these levers, you can change the feed rate of the cutting tool or engage specific threads per inch when single-point threading on the lathe. When these levers are engaged for threading, this will cause the lead screw to turn. For normal turning operations, though, you must ensure that the A, B, C lever is set to C, and that the U, T, S lever is set to T. This data plate provides a user with information on what settings need to be applied for the lathe to perform certain thread forms, or for proper feed rate of the tool when perform cutting operations. Pictured here is the cross-slide, compound, and tool post. The item circled in the picture is the compound. The side edge of the compound base should run parallel to the cross-slide. Pictured here is the tool post and lathe tool holder. The T-nut for the tool post should be coincident to the edge of the compound, as seen in the following pictures. The edge of the compound slide should also be flush with the end of the compound base. In this short video, you will observe the setting of the tool height using the live center on the tailstock. This is a quick and easy way of properly setting the lathe tool height to run on the center of your material. In this video, you will see the lathe operator facing the material. This ensures that the face of material is perpendicular to the side of the material, and it gives the material a nice machine surface. In this video, you will see the operator touch the lathe tool off of the outer diameter of the part and make a series of gauge cuts until part runs concentric with the spindle of the lathe. Then the operator will use a pair of micrometers to measure the diameter of the part, and they will then enter that value into the DRO to establish the x-axis of part.